grading period ends next Friday. I posted this on Google Classroom yesterday. I didn't want to say it before the test. This is a very short chapter. We have 5 days and then the test. So this test is next Tuesday, which leaves us with Wednesday, Thursday, Friday, Wednesday review, Thursday review, cumulative on Friday. So this is the end of your quarter a week from Friday. You have 2 tests that can essentially count as 3 tests. So the next week and a half can make a major difference in your grade. All right, so fill in the blank stuff, start out with the difference between this one and this one is one of them describes a population and one of them describes a statistic. So let's say something like the average GPA of the whole school is, I'll just use easy numbers, a 2.0, but the average GPA of our class is a 3.5. Which one of those would be the sample? Our class or the school? Our class. So that 3.5 would be this thing. That 2.0 is this thing. Because this one described the entire population, the 3.5 just described our sample. This one is a parameter. So a parameter is a number that describes the population. So for instance, mu is population mean. So whatever your value for mu is a parameter. Sigma is population standard deviation. So whatever that value is a parameter. As opposed to if it describes the sample, it is a statistic. So it should be easy to remember the difference between those two. Population proportion, sample statistic. We just did a bunch of samples. Was everybody's results the exact same? No, because there's going to be some variability when we are sampling. This is just called sampling variability. So each of your results of 5 were a little bit different, and each of your graphs that were a total of 21 dots representing samples of 5 were also a little bit different because there is sampling variability. That's going to happen. So putting together kind of what we just did with the front side, back side, essentially we almost never we're going to know what the actual distribution looks like in the real world. We're going to go take a whole bunch of samples and guess what we think it will look like. So we're going to use statistics to estimate what our parameter actually is. So I can use a sample mean to estimate a sample or a population mean, a sample standard deviation to estimate a population standard deviation, and so forth. What is our symbol for sample mean? So I would use X bar to estimate what symbol? Mu. And remember, up until now, we didn't really differentiate that much. Now is when it gets really, really serious about these are 2 completely different things, and don't talk about them separate. Don't talk about them in the wrong way. Because I'm never going to have a mu to estimate what my X is. So then standard deviation, I'm going to have what to estimate what? To estimate sigma. And proportion we haven't talked about yet. This is the first one we start with. The true population proportion is P. The estimated one is actually just called P hat, and it looks like P with a hat on it. And so if it's written, it's literally written as like P hat. You can see it written like that. All right, so we're going to first talk about the difference between population and sample, which which we have addressed slightly before. Gallup poll asked a random sample of 515 adults whether or not they believe in ghosts. Of the respondents, 160 said yes. So, with this problem, and you can only be as specific as the problem is giving you, we're going to define our population, and we're also going to define our sample. In this particular example, what is our sample? So without using the number, which using the number is fine, but I'm trying to do it so you can write it correctly. Which adults were my sample? Explain it as good as the problem does.
Silver asks if he believes in ghosts.
And I'm going to go even more generic. That answer is absolutely fine. I'm going to go, there you go. Ask by this poll. We'll go with that. So I can only be as specific as my problem. What is my intended population here? All adults. Sometimes they're more specific about at least like US or something like that. All right, so I've got my population. I've got my sample. What are these numbers talking about? My population or my sample? My sample. So I'm going to get a statistic out of those, not a parameter. Well, I could write down 160, but I really want it in relation to that, so I'm going to write it as a what? A what? Thought somebody said it. I want the what that believed in yes. So what is my symbol for proportion for a statistic? So p hat equals 160 over 515. I don't think, what is that as a decimal? Oh yeah, that's 0.3107. Yeah. Do I have a parameter in this problem? No, it doesn't give me any numbers for the whole population. That's all it gave me. I ended up changing the instructions for A and B below it, but then I wanted to go back. I'm going to be very straightforward. You're going to see a problem like this. I'm going to ask it exactly like this. It'll definitely be at least on your test. So we're going to write out population, sample, statistic, proportion. If you don't write if it is a statistic or a parameter, then I will have to cut off because you did not differentiate. So on Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. Quality control inspectors sampled 50 bottles at random from the day's production. These bottles contained an average of 19.6 ounces of iced tea. This is kind of something that's like very, very surface level, but more of a real world context of when this happens. They continually monitor what the level is to see if it needs to be calibrated. Never in a working company is it going to go 0.46 ounces off before they ever recalibrate it. But for the sake of our class, it's a good example. So sometimes it's easier to start with sample and work your way backwards. So you can use the number in your answer, and I don't mind if you do, but I'm trying to explain it without that because I don't want you to settle on that's the only thing that differentiates. What is my sample here? What is the number that talks about my sample? 50. Okay, so talk about those 50 what? Bottles what? More specific. By who? That one gives me a lot more specific wording than the last problem did. So because that is my sample, what is my population? Bottles of, I'm putting together things you are saying. And produced what? I'd probably let that part slide because it kind of only generally mentioned it. But technically they could have more than one plant, so we're only concerned with this one. All right, so now I choose to split and write population and then write immediately the numbers that go with it. So here I'm going to write my parameter or parameters. Sometimes it's more than one. So it's got two numbers in bold. Which one of those two numbers is a parameter? 20. So 20 talking about the population. Is it talking about a mean, a standard deviation, a proportion, or something else? Mean. So what is my symbol for that? And what are my units? So even though this is a very short, quick problem, there's a lot here. You obviously have to be able to define the population. You have to know that parameter goes with population and not with sample. You have to know that we're talking about a mean. You have to know that the mean symbol for parameter is mu. And you have to know that 20 is the one that wants the population. So knowing what I wrote here, what should I write here?
Statistic.
And then this one is going to be equals for our class, typically for the most part, we deal with mean, standard deviation, and proportion. You're going to have at least a homework problem that deals with something outside of that. Technically, we could use it just the extent till we deal with things in our class. That's as far as we go. I want you to answer B real quick. And this one's almost a little tricky just because it doesn't like overly obvious say that. Well, I guess it does. What's your population? I know you're writing. Our population is all passengers what? At this airport. So what is our sample instead? Now, is it the one? Okay, let me go backwards. Parameter. What is our parameter here? What symbol first? P equals 0.10. So let's think through this. That is saying 10%. What are we defining as success? Our screened. So our population is all of them. Our success is the ones who are screened. So that concept is going to apply again down to sample. So now what is our sample? And you technically it's at this airport, but if it's this flight that's going from there to there, it's the same group. So then what do I write as my statistic there? P hat equals what? 0.08. And just like before, percents, decimals, doesn't matter. Yeah. And sometimes we're going to get problems where it gives you mean and standard deviation, either of both or of one. You've got to make sure you would have to include both of those there, or all necessary ones there. All right, so this next section that talks about what would happen if, that's essentially what we did at the start. So it says what would happen if we took many samples. If we take a large number of samples from the population, then it starts to look like population. You could calculate the mean or the proportion of each sample, which is what we did. You can make a graph of those values, which is what we did. And then you could examine the shape, the center, and spread, which is what we did. I didn't want to, I deleted the instructions for the way we've done it before, but I didn't want to delete that completely because that kind of just ties into what we did before. The beginning of class activity. So now is the point where if you don't know these, you can't do anything on a problem. So you really have to know what these are. So what does that first one mean? What does mu stand for? What is the second one? So this one's from today, but what is that third one? What's the next one? S. Next one. What is capital N? Population, what? We've talked about this before, but I don't know that we've given a definition. Size is the best thing to call it. Number of sometimes is what people say. So if capital N is population size, then lowercase n is, like I said, this gets to the point where if you don't know these, it really messes you up. I think y'all have done pretty well this year about being okay with those. There have been years past where I've given them a quiz like almost every day on what they are, and it still takes them a long time to catch up. Just if you don't know what those are, you need to know what those are soon. All right, so this bottom part on this side is a little bit of a lead-in. So sometimes we use a subscript letter, so like mu of x, s of x, sigma of x. What does that x actually represent? In general, it's like the group that we're taking it of. So like we either had a variable x when we were dealing with binomial, we had a variable y when we were dealing with geometric. You can always define any letter you want and use it. So it's the subscript is saying this is the variable that I'm talking about. So starting kind of today, but kind of tomorrow, we're going to have something that looks like this, which is a mu of a subscript p hat, a sigma of a subscript p hat, and eventually we're going to have a mu of a subscript x bar and a sigma of a subscript x bar. These are what we did today. So this is the mean, and I just want you to write this first one, mean of the sampling distribution of p hat. So that's what we did today. When we made our graphs, each of our dots was a probability, was a p hat. And if we found a mean of all of our dots that were p hats, that's the mean of the sampling distribution of p hat. So then, I'm not going to make you write it, but what's the next one going to be? Standard deviation of the sampling distribution of p hat. We're going to talk about that more tomorrow, though. Like I said, that's kind of more of a lead-in than anything else. I'm just going to split